Welcome to homework.
So at lower pH, the carboxylate ion takes up a proton, while at a higher pH, the amine group loses a proton. Let me represent it. So starting with low pH, OH, double bond oxygen with NH3 positive. And the other one is at high pH, oxygen negative, double bond oxygen and NH2. At low pH, amino group get protonated, while at high pH, carboxylic group get deprotonated. To the part B, let me represent the reaction first. OH, double bond oxygen plus OH negative gives me oxygen negative plus water molecule. So we have acetic acid along with strong base that gives us carboxylate ion. Likewise, when ammonia is treated with the strong acid, it forms ammonium ion. The representation is hydrogen, nitrogen, hydrogen plus hydrogen. We have NH4. This is ammonium ion. For the case of molecule serine, INE, we have low pH first, OH, NH3 positive, double bond oxygen, while for a high pH, the representation will be oxygen, oxygen negative, OH, NH2 along with double bonded oxygen. Continuing to option number C, for glutamic acid, a different group that gives a pKa value can be shown. Here we have three groups, double bond oxygen, NH2, OH, double bond oxygen, oxygen negative, oxygen negative, NH3, NH3 positive, double bond oxygen on the both side. The first group gives pKa value as 4.07. The second group gives pKa value as 9.47, while the third one gives 2.10. So from the given graph, the pKa value, pK2 value, and pK3 value are already provided, almost assuming as 2.0, 4.0, and 10.0. The graph obtained from the titration of amino acid is characterized by the pK2 value, while pK1 value is 2, that mainly corresponds to carboxylic group. So pK2 will be carboxylic. pK10 corresponds to amino, and The graph obtained from titration of amino acid is a characteristic property of amino acid with one extra carboxylic group, which will be pK2. So, drawing the diagram of aspartic acid and the second one of glutamic acid, let me represent double bond oxygen, NH3 positive, oxygen negative. This one is aspartic, so glutamic will be oxygen negative, double bond. We have NH3 positive, oxygen negative, double bond, oxygen. So the first group will react to pK2 value. Third one represents pK3, while the last one is of pK1. Hence, the carboxylic acid which have one extra carboxylic acid are aspartic acid and glutamic acid. We have shown the structural representation as following.